Hi guys. Today, well, it's the same day that we're recording this, but we're about to do the convection lesson. Yesterday we did conduction, where we talked about popping the popcorn. Today we have another experiment, but before we start that, you need to make a flashcard for the word conduction for yesterday's lesson. So what you need to do is, I like writing on the blank side the word conduction, which, Ms. Dawes, can you hand me one of those markers? Don't use the Sharpie. I was about to use the Sharpie. They bleed through, and then you'll be able to cheat, which defeats the purpose. So I'm going to use a different marker that's not a Sharpie. And I'm going to write conduction on my card. Okay? After I write conduction, I'm going to write the definition on the back. You see how I use this marker? You can't see through? That's perfect. Okay? So what I'm going to do now is, all right, so what I'm going to do now is I'm going to write the definition. I'm choosing a different color just because I'm being fancy. So what conduction is heat transfer through touch, or you can say direct touch. So I have conduction here, and then I have heat transfer through touch, or you can put direct touch. All right, so now I have a Ziploc bag. If you don't have cards, they don't have to be pink. Mine are just pink from last year. If you don't have cards or a Ziploc bag, you're gonna need to ask your parent or your guardian to go out and get it for you, because they should have been on the supply list where we asked you guys to get stuff at the beginning of the year. So, but I am gonna take my Sharpie and I'm gonna write on my bag. So on my bag, I'm going to write heat transfer, because that's the name of the whole unit. We're going to do heat transfer for all of quarter one. Heat transfer for Q1. And since this is, which I know this is hard to see, so there you go. It says heat transfer Q1. And then I'm also going to put my name at the bottom, because this is my bag of flashcards. And I know you're probably like, why do I need to put my name on it? I'm the only one in my house that needs these flashcards. Yes, but we're going to be optimistic that we're going to come back to school sometime this year, and that way everybody will have the same thing, so your name will need to be on it. This should go in here. The only flashcards that should go in this bag are the ones for quarter one. So the heat transfer ones. So after, I think like October 16th, 17th, 20th or something like that, it'll be a new quarter and you'll have a new bag. You won't have to fill this bag anymore, but you will have to keep studying these words. And we have a YouTube video for how to study your flashcards. You can go to that for how to study. Okay, so now we're gonna start today's lesson of convection. And actually up on the board here, this is also, if you have an all white card, you can do it in pen, you don't have to do it in marker. As long as you put conduction on the white part, and then the definition, Ms. Stiles has direct touch on hers, you'll be good to go. All right, so now we did the conduction lesson yesterday. So this is what your page should look like. It should be all filled in from, actually, we go up to the tab at the top, Ms. Nevins, Ms. Stiles, so I can show Ms. Nevins. So this is my copy of the science notebook. So all of this information should be in the one with your name on it, okay? So now Ms. Stiles is gonna go to present again. And this is what I've done. I've copied and pasted my picture in here from yesterday, my after picture. And then I filled in my hypothesis down here at the bottom. And what I'm going to do later is I am going to link, I'm going to send this notebook to all of you, but it's only going to be view only. So you're not going to be able to edit it. And this right here is the link to yesterday's lesson. It's just the lesson from the YouTube channel. So you can reach it there. Look, it's the convection lesson. Or you can go to the YouTube button on our homepage and click that and get there that way. Yep, right there on Miss Stiles' page, and then mine says YouTube with the symbol on my page. I think Miss Stiles is going to show it right now. So there it is on my page. You just click there, and you can scroll through all of our videos and see our YouTube videos. Okay, I filled in my hypothesis from yesterday, what actually happened, and the results. And so now we're going to go to the next page, which is why do fluids move? And also what you should know is that fluids are liquids and gases. Yesterday, did I spell gases right? Sorry, I'm a horrible speller, y'all. 2 S's? I don't know. Anyway, so yesterday we talked about conduction was 2 solids touching. Today we're talking about fluids, which is liquids and gases. So we have a before picture, which you all will have in your science notebooks, or you'll put it in there, I can't remember. And it's got a picture of our experiment today. Here. All right, it has a picture of our experiment today. We're going to do one that has to do with water, and then we're going to do one that has to do with air, because remember, fluids are liquids and gases, and air is a gas. All right, so I've done my hypothesis already in my notebook for today. So we're going to say, why do fluids move? Why does the dye move? So this still has to do with heat transfer. This experiment has to do with ice and hot water. So our hot water is going to be the heat. And this experiment has to do with a paper snake Miss Stiles made and the burner, which is hot. So both of these experiments still have to do with heat transfer. So, but what we're asking you is, why does the dye move? So we are taking dye, a red dye and a blue dye, look like this, I don't know if you can see, and we are going to place them, we're going to bloop, 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 into the water, and we want to know why the dye is going to move. So my hypothesis, I think the dye will move because water moves and the dye will be in the water. That's my hypothesis, okay? It's already going to be wrong because it has nothing, my hypothesis has nothing to do with heat. But I put a wrong hypothesis up there to show you that it doesn't matter if it's wrong. All that matters is that when you get here to the last step, you understand what happened in the experiment and what convection. All right, so I've already filled in my hypothesis. What I want you to do is fill in yours. Don't write mine down because it's wrong, okay? But I want you to remember, you're saying, why do I think the dye moves? Remember, we have ice and we have hot water. Why do you think the dye is gonna move when it enters the bucket with ice and hot water?
Okay, we are going to show you one more time because we don't think our water was hot enough. What happened when we put the dye in. So we got really cold water, it's all the way filled up, and really hot water from my Keurig.
Yeah, now you can see.
So Miss Nevin's going to put the red dye on this side, the blue dye on that side. I'm going to put enough that you can see it, and we actually turned it so that you guys can use the sunlight to see the water. With lots of dust. All right. So you can already see the difference is The blue dye seems to be settling right there. It doesn't seem to move much. But the red dye is already dissipating and going around.
Spill.
Yeah. Miss Meta gem. There we go. Beautiful, Miss Meta. So you can see how much the red has expanded and moved versus the blue, which is only in one spot. I can show you up or top. For the side is probably the best view that you can see. So you can see that the red is moving up towards the top and now is moving towards the middle. And the blue hasn't really moved, it's just sitting around the bottom. So we're going to continue to watch it for another minute.
Show it from the top now. It looks like a red arm. So do you see how the red is stretched out in the middle? It's a little pink there, but all the blue is on the same side. Now, some of the red is starting to touch the blue, and the blue is moving a little bit faster.
So you can see that the blue is still all settled at the bottom. The red is moving.
And the red is moving up. The blue is moving, but it's moving at the bottom.
It's moving right along the bottom, as you can see right here. And the red, it's a lot of it is still right there, but it's pushed up and now moving over.
This one's way better there. You just gotta make the water hot. You let it sit on the desk too long.
Okay, so now you can see that the blue is almost all the way over to the red.
On the bottom.
On the bottom. So once it gets over to the red, something new is going to happen. Get rid of this conversation right here. We'll learn that word soon. So once it gets over here, now the blue, you can see, the blue is starting to rise. So once it gets over the water, it's starting to go up. And now the red is dissipating over here and getting over the cold and starting to fall down. Watch that. So we just need to make it a lot hotter.
What actually happened part.
Yes.
Which I already have it typed in, but now we're gonna pause it so you can type in what you observe. Make sure that you talk about the red dye and the hot water and the blue dye and the ice. Make sure you have those words in your what really happened. I'm gonna give you time to do that now. All right, guys, so we're back. Yes, the dot's moving. Okay, we're back. So you should have filled in, it's not up there, but what actually happened. So now we're going to read about convection and then come back to what actually happened. All right, so convection. Radiators can heat the air. Convection moves the warm air from the radiator throughout the room. Radiator is just like a heater. Convection is a process in which a liquid, remember a liquid can be a liquid, or actually no, I thought that was fluid. It says fluid. Convection is a process in which a fluid moves from place to place. And remember, a fluid can be a liquid or a gas. Can't be a solid though. A fluid is a substance that flows but has no definite shape. Air and water are fluids. So what that means is if you fill a square container up with water, then the water is going to be in the shape of a square. If you fill a square container up with air, then the air is going to be in the shape of the square container. Now, if I put this marker in the square container, is it going to turn into a square? No, because it's a solid. It's not a fluid. It's going to keep its shape if it's a solid. All right, so air and water are fluids. A convection current is a pattern of heat energy. hot air or water rising and cool air falling or cool water falling is a convection current. Warm air from the ground expands and rises up towards the sky when we're talking about weather. At the same time, cold air sinks, causing a convection current. The cool air then becomes warm and is forced up. The pattern continues in this way. So boiling water in a pot is an example of convection, because if you look at the picture, what happens is that pot is sitting on that burner, remember? And that burner is hot. So what happens is heat transfers from the burner to the pot by conduction because the burner and the pot are touching. But the water inside the pot is making a convection current, because what happens is the bottom of the pot is hotter than the top, okay? Because the top of the pot is not touching the burner. So the water at the bottom of the burner is hotter than the water at the top, even though it's both hot. I'm not saying stick your hand in a pot of boiling water because the top is not hot. No, I'm just saying that the top is cooler than the bottom because the bottom is closer to the heat source, which is the burner. So when you are boiling water, that is convection because the water that's at the bottom heats up and it shoots up, it bubbles up and it rises. Once it gets to the top, it cools and then it sinks back down. But then when it gets down there, it gets real hot and it bubbles back up to the top. And it's gonna keep going around in that circle, and that's why the water boils in a pot. All right, so the next line or paragraph says, look at the tank of water on the next page. The dye allows us to see the convection current, which I'm gonna flip, we just did that. The dye allows us to see the convection current. The heat source warms the water, which mixes with the dye. The warm water rises because it is less dense, which we're just gonna say it's lighter. It's less dense than cold water. As it moves away from the heat source, it cools and sinks to the bottom of the tank. It then moves back toward the heat source. This will make it rise again. So this is literally what we just did. Our picture looks way better. But what is happening is the water over the hot water was hot. So that dye rose up and then it kind of shifted over. But then when it got to the cold section, it's gonna sink. But then when it sinks, it's gonna shift over on the bottom and get back into the hot section and go up. So it literally makes a cycle, which is why it's called a convection current, because a current is like a cycle. Okay, so I don't know if you guys can see. I think you can.
Okay. So you can see how far the blue has gone over the bottom. You really can't see because the red is like turning the color of all of the water now, but the blue is covering most of the bottom for the entire thing now.
So, and that also helps with saying that like things that are warm move faster and things that are cold move a lot slower. So like if you've ever played like basketball outside or football outside or some sort of any activity that you can do with your hands outside in the summer, it's easy. Like you're sweating, you're throwing the ball, you're shooting, you're jump roping, it's easy. But then it's like sometimes when it's winter and it's cold and you want to catch a ball, it hurts and things just move slower. Because when things are cold, they compact and they come together. Like when you're cold, if you're outside with no jacket and you're cold, you do this because cold things come together. But if you're outside and it's hot, you don't want to do this. You want to spread out because it's hot. And that's exactly what the particles and the molecules do inside of objects. When they're hot, they spread out. When they're cold, they come together. When they're hot, they move around. When they're cold, they move real slow. All right, so this page, I'm not going to read that bucket part, but I'm going to read the other side that says, large convection currents shape our weather. During the day, air over the land is heated and rises. Cool air from over the water blows in underneath to take its place. During the night, the water is warmer than the land and the convection currents are reversed. So that's talking about land breeze and sea breeze, which we will talk to you about during our weather unit. All right, so now let me take you back to the science notebook. Ooh, just kidding. Let me stop sharing my screen. All right, so now what actually happened? My bad. Okay, so what actually happened, I have mine, it's real simple. I put the red dye on the hot water side, moved up, and then I put the blue dye on the ice side, moved down. So like we dropped it in, it went down, and it stayed down. The red dye, we dropped it in, and then it rose back up, which is pretty cool. So that's what you should have done for what actually happened. Now, what we're going to do is we're going to do another experiment called Why Does the Snake Move? Okay? Now, in this picture, you've got the burner. We need the burner again because we always, our essential question is how does heat move? So every single one of our experiments is going to have a heat source. The burner, the snake. All right, so now we're going to do the experiment, but I'm gonna pause it real quick. All right, guys, we're back. I know you can't see my face. It's not important right now. So you can see Miss Styles in the background. She has a paper snake. So when she holds the paper snake out, it moves a little bit because we're in this room and the air conditioning is pumping. It's freezing in here. But what she's gonna do is put the snake, oh, she had the snake over the burner, and I don't know if you guys can see the smoke from the snake, but it's rising up. And what that smoke is doing, this is definitely not steam, this is like grease on here that's smoking.
It smells really bad.
I just inhaled it. So the heat from the burner is rising. Heat always rises, and the smoke is an excellent example of that. The heat from the burner is rising up because hot things always rise. When you light a match, the tip of the fire from the match goes up because hot things always rise. If you've ever been on a bunk bed, if you're on the top bunk, it should be warmer up there than if you're on the bottom bunk because hot air rises and cold air sinks. Just like in our experiment earlier with the bucket of water and the dye, the hot water with the red dye, that side rose to the top. And then the cold, the ice with the blue dye stayed at the bottom. And what happens eventually is it makes a convection current. The hot air or water will rise. When it gets to the top away from the heat source, it'll sink. And then when it gets down to the bottom next to the heat source, it gets hot again and it rises. And then it sinks. And then it rises. And then it sinks. But what you have to know is convection is when hot air or water rises and then cold air or water sinks. And then it goes in a circle, which is why it's called a convection current. All right. Hey guys, we're back. Sorry, I'm still learning Zoom. Okay, so we have got our before picture of the first experiment, our after. We've got our hypothesis, what actually happened. Then we did our snake experiment. We did the before picture, the after picture, and we've got after reading, why did a fluid, remember that's air and water, why did it move? So, my explanation, yours doesn't have to be like mine. I'm the teacher, so I make it real detailed. But the more detailed it is for you, probably the more you understand. But mine says the hot water from the first experiment moved the red dye up to the top of the container. The ice kept the blue dye from rising up because it was cold. And then I put in the second experiment, the hot air, or in our case, the smoke, because the burner was smoking, from the burner was rising up and moving the paper snake. And then I put convection is when hot air or water rises and when cold air or water sinks. So after I fill this in, oh, I need to go to my heat moves at the first slide. So after I fill this in, I need to go back to here. And actually I did the conduction part on the
board.
I did it on the board and I didn't type it. So what I'm gonna do is I'll type it in. So when we do the radiation experiment, it'll have conduction and convection up there. But since I'm at the board, we're gonna put, this is what it should look like when I finish. I'll have my conduction words from the first day. And then I'm gonna switch colors. Convection is when hot air or water rises and cold air or water sinks. All right, and this will be typed in when you get to the convection part. So at the end of this experiment, at the end of these experiments, you'll have a conduction section for why does heat move, a convection section for why does heat move, and a radiation section. And then you'll know that the 3 ways that heat moves is through conduction, convection, and radiation. So I'm going to go ahead and erase that only because I'm going to type it in later. You don't erase. And don't do the squiggly lines for conduction. All right, so now we finished our convection experiment. So what do we have to do? Make a convection flashcard. So I have convection on this side. I'm going to put the definition on this side. So my definition is, and I can't put the word convection on the back because then when I'm studying, I'll see what word it is and I won't be able to quiz myself. The word only goes on the front. The definition only goes on the back. So I'm going to put hot air and water rises and cold air and water sinks. So this says convection. You can write convection. You can write convection current, doesn't matter. So I've written this. I've written my definition. And then what I'm going to do is I am going to take and put it in here so that when I go to study, I will have all of my heat transfer words in a bag. All right, thanks guys for watching our convection experiment. The next time you see us, it will be for our last and final heat transfer, which is radiation. Bye.